Hey everyone, welcome to another chemistry topic together. This is the first day of our unit on atoms and compounds. So the idea is that now we know a lot about matter, kind of in general, and now we're going to get into the really specific details because as a chemist, the details really matter. So we're going to get into the smallest thing we can talk about, which is atoms. So that's going to be our focus. All right. Well, the atom is tiny, but we kind of make a big deal about it. So you might be thinking, why do chemists make such a big deal about atoms? Like, why is that something that we have to talk about? When am I ever going to have to care or know about this? Well, here's the thing. We've been studying that tiny thing for hundreds of years. And the idea is that we are trying to explain anything we can at the smallest level. Because if we can understand it at the smallest level, we can make changes to that smallest level, which will create new atoms, new compounds, new medicines, new fuels, new plastics, new cleaners. Everything starts at the atomic level. So, as a chemist, which I want you to think of yourself as when you're doing class with me, is that you need to know about the tiny little things that make up everything else. It would be like if you were trying to read and you didn't know what the letters meant. So you needed to know your alphabet before you could understand words, before you could understand sentences and start to read and put your language together. Well, that's how chemistry works. If you want to understand the really cool reactions and changes that are going on, you have to know what's happening to the atoms, the tiny pieces that make it up. So that brings us to our topic for today. Go ahead and set up your focus notes. Our topic is atoms, ions, and isotopes. The date that I am making this before you is 12/21. You write down whatever date you're taking these notes, but that's the day that I assigned it. And the EQ is, what is the difference between atoms, ions, and isotopes? So those are the pieces that we're going to talk about today. And then the next day together, we'll start talking about putting atoms together and compounds. So today we're going to focus on atoms or elements. Think of it that way. We talked about that in our last unit. So stuff on the periodic table, that is our focus. And once we know about the stuff on the periodic table, that's like knowing your alphabet. We can start putting things together like words. That's like compounds in chemistry. So we can eventually understand full reactions. That's like sentences and reading paragraphs and stories. So that's what we're going for. Here we go. The first thing I want you to do is I want you to draw the basic structure of the atom. Remember, you only have to write down stuff that's in red. So this arrow is showing you this is what you need to write down. So what I want you to draw is something like this. I want positive pieces in the middle and neutral, just open particles in the middle, and then negative pieces around the outside. This middle part label the nucleus. Inside the nucleus, there are neutrons, which are these blank ones, and protons, which are positive. And then the electrons are negative, flying around that outside. And then this is what you write down by your picture. The electrons can be described as being in energy levels or in the electron cloud. So we described the neutron and the proton as being inside the nucleus. So that's why we didn't have to write anything separate because you already have it labeled in your picture. So again, you're drawing this picture, pause the video if you need to, and then write this down. So electrons can either be described in energy levels, like close energy levels to the nucleus or farther away energy levels, or in an electron cloud, which is like this pink stuff in the picture. That is the basic structure of the atom that has been studied for years and years and years and years, and we've actually never seen one. That's always the tricky thing. Like in biology, you think about cells, and you can look at a cell under a microscope. We don't have any powerful enough microscopes where we can actually see inside what one atom looks like. So all of this is just a model based on other things we have observed. And that's kind of a cool and tricky part of chemistry. All right. So if we establish some of these words that are related to atoms and we kind of know the basic structure, what gets interesting is when we start changing this structure. And that's part of what we're going to talk about today. The first thing, though, we need to answer is, why does it stay together? Why does the neutrons and the protons stay here? Why do the electrons stay here? Well, there's two reasons the atom doesn't just fall apart or smash in on itself. One reason is because of gravity. Gravity is any two things that have attraction or next to each other. So like I'm sitting at my desk and I have a water bottle near me. There is gravity between my body and that water bottle. we usually don't think about the gravity between different objects sitting around each other because the Earth's gravity, because the Earth is so huge compared to my water bottle, the water bottle and the Earth's gravity is so much more than the water bottle and my gravity. That's why we don't notice it. However, if you're a tiny atom, the gravity between protons and neutrons is a lot, and that keeps it stuck together. The protons and the electrons stay together because opposite charges attract. So the positive piece and the negative piece want to be near each other. Now, the reason the electron doesn't get pulled into the nucleus is because the electrons are flying around the outside. So, because they're moving. So, imagine it like if you're playing tag, it'd be pretty easy for you to catch someone if they just stood still. But if they're running around, you're also going to run around and kind of chase them. So there's that attraction, but it's harder to catch them because they're moving. That's kind of what's happening with the atom electrons and the electrons that are negative and the protons that are positive, or really the whole nucleus is positive because of those positive protons. So the electrons want to be near the positive pieces because opposite charges attract, but they don't get pulled in the nucleus because they're moving. So that's why the atom stays together. That's why it doesn't just fall into little pieces. All right, that's actually our first break already. So we're going to think about a level 1 question. The reason I have you do this is because it makes your learning more active. So you're not just sitting there listening, because research shows that you only remember about 4% of stuff when you just listen. You remember a lot more when you take an active role. So you're going to write Costa questions about what we've done so far. You could draw a picture and say, identify the parts of the atom. You could say, you could draw a partial diagram and say, complete the rest of this structure of the atom. Name the particles inside the atom. Any of those kinds of things. A level 1 type of question about our notes so far. All right, come on back. So now we want to talk about it. Again, we talked about changes, chemical and physical changes in our last unit. Changing is what's interesting in chemistry. So let's talk about changing the particles in the atom. So what if remember, you only have to write this stuff in red. What if I change the number of protons? What will happen? That's how you get new elements. In fact, some of the elements on the periodic table, the bigger ones, are made because we have blasted a smaller atom that split up the protons in the nucleus and created more protons. And then that can create a new element. Now, those elements don't stay very long. We just call them lab-made or man-made because those protons don't want to stay separate. They want to fuse back together. So anyway, that is how you get new elements. So if you look on the periodic table, the number that goes in order from 1 all the way up to 118, that is the atom's number. It's called the atomic number. That tells you how many protons there are. So no two atoms have the same atomic number or the same number of protons. If you change the electrons, it still is the same identity, but you get something called an ion, which we're going to talk more about that later. So don't worry about that right now. Just write down this vocab word, ion. Ion has to do with being positive or negatively charged because your electron is negative. So if you get more electrons, you're negative. If you get less electrons, you're positive. Again, we'll talk more about that in a little bit. But when that happens, we don't call it an atom anymore. We call it an ion. The last option would be the neutron. So what if I change the number of neutrons? So again, you're not going to change the identity. That's only the protons. But what you do change is you get something called an isotope. So generally, the idea is that a neutron is related to the mass. And so you either get a mass that is heavier or lighter based on what happened to your neutrons. So this would be kind of like if a person loses weight or gains weight. They still are the same person, but their mass or their weight would be different. Electrons, when you change them, that's kind of like when a person is in like a good mood or a bad mood. So it's still the same person, but you're either feeling positive or negative depending on what's going on. That's kind of what an ion is. So an element is related to the protons. That is what is your identity. You can't change the protons and keep the same atom. But if you change the electrons, you get what's called an ion. If you get a neutron or change the neutrons, you get what's called an isotope. So now we got to talk about these 3 words a little bit more. What really is an atom compared to an ion compared to an isotope? But we'll do that in our last part. So right now, do your second brain break. So a level 2 kind of question. Remember, level 2, there's a hint in the notes, but then you have to fill in the rest of it. So you could do a compare and contrast. Compare an atom to an ion, right? Or contrast. What's difference between an ion and an isotope? Those would be good too. All right. You read a level 2 question and then come on back. Let's finish it up. The next thing I want to talk about are atoms, ions, and isotopes. Let's start with atom. So an atom is a neutral particle, and inside that particle, there are subparticles called protons, neutrons, and electrons. So that's how we started our notes. That picture that you drew, that's what an atom is. It is the whole atom is considered neutral because the protons, which are positive, and the electrons, which are negative, balance each other out. The atom is defined by the number of protons. So every atom on the periodic table has its own number of protons. And this number here that goes in order 1, 2, 3, 4, 5, 6, all the way to 118, those are the number of protons. It's defined by that thing called the atomic number, the atom's number. The atom's number tells you the protons defines what atom you're talking about. So if I pick any number, I don't know, let me pick 32. If I find element number 32, here it is, that tells me that I'm at germanium. There's no other atom that is number 32 or has 32 protons. That's what defines it as germanium, or that atom. Helium has 2 protons. There's no other atom that has 2 protons. It's what identifies it as helium. That is what makes helium different than anything else. 2 protons. That's what an atom is. So it's defined by the atomic number on the periodic table. If you've not already printed or put a periodic table into Notability, remember to do that because we're going to use our periodic table a lot from now the rest of the year. So you want to make sure you've got a periodic table that's easy to find. You can put it from Schoology, print it off if that's an option, then you always have it, or put it in a Notability so it's easy to find. All right. And then atoms are really the elements on the periodic table. So atom and element is really equal words. So these are all the different atoms that we've discovered or created. These are all the different elements that we've discovered or created. So an atom is really just the periodic table of atoms, periodic table of elements. Same idea. Okay, that's what an atom is. Let's talk about an ion next. Well, you might have heard of a Saturn ion, the car, and I like to say it's an attractive car because an ion is something that has a charge. And when you have different charges that are opposite, they attract. So that's the funny joke. Ha ha ha, Miss Killinan, right? So this is an attractive car. It must be because ions have charges. The definition of an ion is now you, instead of it being an atom, it's an atom with a positive or negative charge. Because remember, atoms are neutral, but an ion is special. It's not an atom anymore. Now that particle is either positive or negative. If you have less electrons than protons, that means you have less negative pieces and more positive pieces. The ion is a positive charge. If you have more electrons, electrons are negative. So if you have more negative pieces than positive protons, the whole ion becomes negative. That's important to realize. So more electrons means more negative, less electrons means less negative or positive. We will sometimes need to write ion symbols to show what's happening to that element so that it can connect with other elements. That's what we're going to start learning next. So what we do is you find the symbol on the periodic table and you write the charge as a superscript, like an exponent kind of. So if, for example, if I wanted to say that oxygen has 2 more electrons than protons, all right, more electrons. So more electrons means it's negative because electrons are negative. The symbol, if you look on the periodic table for oxygen, is capital O. 2 more negative pieces means it would be a -2 charge. So this tells me that I don't have the oxygen atom, I have the oxygen ion, and it's a negative ion, which means it has more electrons than normal. Or calcium with 2 less electrons than protons. I look on the periodic table, the symbol for calcium is capital C, small a. Be picky about those capitals and lower cases, they matter because capital letters means it's a new element. Lowercase letters means it goes with that same element still. So if you have a capital C and a capital O, those are 2 separate elements. Capital C, small o is 1 element. That's why that's important. All right, 2 less electrons means less electrons, less negative pieces means you're positive by 2 parts. So Ca with a +2 charge. This is an ion symbol that tells me that calcium has lost electrons. It has less electrons than normal, so it's the calcium ion. What we're going to start talking about next is, well, look, this is positive and this is negative. They'd be attracted to each other. They could make some type of compound. So that's eventually where we're going next. But right now, we're just learning about ions and atoms separately. One more term to learn about. What was that thing again? Isotope. So that's our last term to define. And think back, do you remember what changes in the atom to make it an isotope? Do you recall? Get that brain thinking? Yeah, the neutron. So an isotope is an atom that now has a different number of neutrons. So it doesn't change the charge, but neutrons are considered kind of heavy. So it changes the mass is a big deal. So when you have an isotope, we have to show that the mass is different. In fact, we have to know something called the mass number. So you can write the full name of the atom, the element, and you put the mass number behind it. So like this, gold with a dash, 201. So this is not a negative charge, because remember, if it was, we would use the symbol and we would put that negative way up top like an exponent. This is the mass number. So this tells you that it's related to how many neutrons and protons there are, and that number would change if you have a different isotope because the neutrons would change. You could also just write the symbol instead of the name and put the mass number in front of it like this. The symbol for gold is AU, and you put the mass number in front of it. So these are both the same isotope because they have the same mass number. There's just two different ways to write it. So then what I need to tell you for now is, well, how do we get that mass number? Because that's not on the periodic table. Well, there's three different ways you can find the mass number. If you know the number of protons in the nucleus and the number of neutrons, add them together, that's the mass number. So that's why if you change the neutrons, you change the mass number for the isotope symbol, because neutrons plus protons is the mass number. The other thing you could do is if I gave you this symbol, that gives you the mass number like this. So if you already know or are given the isotope symbol, that number given is the mass number. Now, the third option is that if you're trying to predict the mass number, you look at the periodic table and you look at the mass or the atomic weight, and you get the most common isotope's mass number. So, for example, hydrogen's atomic weight or atomic mass is 1.01. If you round that to the nearest whole number, it rounds to 1. So hydrogen's mass number is 1. That's it. If you look at boron, the atomic weight or atomic mass is 10.81. If you round that to the nearest whole number, that would be 11. So boron's most common isotope's mass number would be 11. So if I wanted to write the isotope symbol for boron, I would say boron-11 or 11 capital B. So just showing you how we write isotopes. So if you see that format somewhere, you know what that means. Okay, so now we know there's ions, isotopes, and atoms, all related to the different particles inside an atom. That brings us to the end of today. So now you're going to do a level 3 kind of question. Open-ended, brainy, creative kinds of questions. Things like defend learning about the atom. So let's say that there was someone that was like, you can't teach atoms in chemistry class anymore. Defend why we should be able to teach it. Or design an early model of an atom, like before we knew about protons or something like that. That might be kind of one. Or predict what's inside a proton, neutron, and electron. That might be kind of thing. So some type of level 3 question. Go ahead and write your own. You can use these ideas, or you can use that Costa Questions guide on Schoology. All right, that brings us to the end of our first day of this new unit. So here's the things I want you to do. Go back and finish any Costa questions, and then write your summary for today. And remember, the summary should be a sentence that answers the EQ. And the EQ for today is what's the difference between atoms, ions, and isotopes. The other thing I want you to do to review today's notes is there's an atoms, ions, and isotopes worksheet quiz on Schoology. Let me explain what a worksheet quiz is. It looks like a Schoology quiz, but it's a practice assignment. You get unlimited attempts. So if you get something wrong, look at the ones you got wrong, look back at your notes, see if you can find the right answer, take it again. You can take it as many times as you need to learn the right answers and to get a perfect score. That's the point. So it's a 10-point practice assignment that just helps you review these notes in a little bit more structured way. Plus, you get immediate feedback to know if you have the right answers, If you don't have the right answers, you review your notes, look at the right answers on the quiz, retake it until you get a perfect score. So it might take you a few attempts if you need to, or you might get it on the first time. Either way, take it as many times as you need to get a perfect score so that you would learn the correct answers to review today's notes. All right, that brings us to the end of our Zoom or our online session as the notes section. And we will see you at our next Zoom. Thanks for listening. Bye.